Good afternoon. Can you hear me? Sound good? It's like we got a big old room here. This is great. We appreciate y'all coming in. My name's Robert Gillies. I work in Microsoft Services. I'm a senior architect, and I work in the U.S. Department of Defense area. So I work with our Army, Navy, Air Force, Marines customers. My buddy up here, Adrian. Adrian's from the UK. Adrian's a PFE out of the UK. And who are your customers?
Transport for London and Essex County Council. Look after.
Okay. And my good buddy Boris here is from California now, and he works with a lot of our other customers. Boris is a consultant, principal consultant, I'm sorry. And so we've got basically the three roles of Microsoft Services represented here. One thing I wanted to tell you about Boris, Boris has one of the most interesting backgrounds of anybody I've ever worked with. He's done a little bit of everything, from deploying Exchange to some of our biggest cloud competitors. He deployed Exchange at that competitor. To back when he lived in Russia, Boris was a math professor, and he wrote some papers. And here's the name of one of these papers, right? N equals 4 conformal supergravity and irreducible superfields. And I told Boris that I wanted to give links to all these because I think it's amazing that he writes papers that I don't even know what the words in the title mean. He wouldn't let me put it in there. So if anyone wants links, you can either look him up or you can send me an email, and I'll send you links to Boris's papers. But anyway, so we'll get started on this. Our presentation is called Design Your Exchange Infrastructure Right, or Consider Moving to Office 365. And we've presented this a few times inside of Microsoft, and we don't have to be quite so politically correct there. We like to call it Do Exchange Right or Move to Office 365. And to be a little soften that a little bit to present it here. But we're going to talk to you a little bit about this. So hand this off to Adrian and let him
Thanks, Robert.
Explain what's going on here.
So there's been a few sessions this week about the preferred architecture. Ross done some stuff earlier. So we're going to cover some of that again. We really want to drill that into you. But today we hope you get out of this is a good knowledge of the preferred architecture, but also an understanding of why we recommend what we recommend. Not just the fact that we recommend it, we're going to make you understand why we do that. So key takeaways here are keep it simple. Honestly, that is the key takeaway from this session. Keep it simple, please. And if there's no way or reasons that you can't deploy the preferred architecture, then we say, come to the cloud. We can do it for you. We got cookies.
And ponies.
And ponies. So design principles and preferred architecture. So anyone here not understand or not heard of the preferred architecture? No hands, that's good. That's good. So who here is purely on premises? Whoa. Got some work to do.
It's more than half. That's what I'm seeing.
Okay, a hybrid? Wow. Okay. So let's look at a picture of the preferred architecture. Oops. Honestly, this is where we want you. This is where all the innovation is happening. This is where all the good stuff is. This is where the cookies are, all right? But there's an on-premises preferred architecture, as you know. And I'm going to hand over to Boris to take you through that.
So since the preferred architecture, as Adrian showed you, is real Office 365, and that's where the cookies are, how do we get there? Where is that path to these cookies? How can we achieve that simplicity that Adrian emphasized in the introductory slide? How you can get into that Exchange nirvana that all of us are experiencing in the cloud? Quite honestly, in the very short one line, the answer is very simple. Just understand and follow the design principles of Exchange. Because if you know and understand design concepts, then you can address pretty much any design challenge you have in your environment and deploy Exchange properly, and it will work well for you. So let's look at these design principles, but in order to understand them better, let's take a very quick trip down the memory lane first. So about 12 or 13 years ago, when we had Exchange 1003, right, it was a great version, How many people here had deployed Exchange 2003 and remember those times? Oh, great. Nice. We have a lot of experience in this room. Okay, so at that time, Exchange, quite honestly, did not know much. It was relying a lot on the underlying infrastructure to deliver necessary performance and to deliver necessary communications. So at that time, when Exchange databases required a lot of IOPS, you had to deploy Exchange on the SANs with all the sophistication of the SAN, with the fastest enterprise class drives and all that jazz. You all remember those times, right? But now, Exchange is much smarter. And that evolution that brought Exchange from 2003 to 2007, 10, 13, 16, it was getting better and better and better. I/O requirements were going less and less and less, and slowly we came to the new architecture and new understanding of what Exchange should look like if you really want to build the inexpensive and very scalable model of the Exchange deployment. So the pictures kind of illustrate it. So let's see what are those design principles that we understood and elaborated over time. So we tried to group it here into 4 cornerstone pillars, right? And those pillars are availability, functionality, operations, and cost. So seriously, who needs the solution if it's not available and fails all the time, right? Who needs the solution if it's stable like a rock, but it does not give the functionality that users need? Right? The users cannot do the tasks they need to. Who needs the solution that is solid as a rock and provides all necessary functionality, but you have no idea how to operate it, so you cannot really deploy it or configure it properly? And finally, given that all 3 that are there in place, but if that solution costs $10 gazillion, are you going to buy and implement it? Probably not. So the key here, the key pillar that we want to focus on during the next few minutes is availability. And the key to understanding availability principles is that in the modern world, remember I just said a couple seconds ago that Exchange is now very sophisticated and it became smarter, is that really software now, not the hardware, powers and controls the solution that you build. What does that mean when we start talking about Exchange? Where is my next slide? There we go. So in order to illustrate how availability could be achieved in the Exchange solution, we need to understand 2 things. When you build the solution, any sort of solution, right, it applies not only to Exchange, to anything. Your final solution consists of multiple components, solution components. Those are critical solution components. If they are not there, solution simply cannot function. Exchange, for example, does not exist in the vacuum, right? It relies on Active Directory. It uses Active Directory. It needs network. It needs storage where the mailbox databases will be hosted. So you easily follow that idea. So when we have a lot of those solution components, that decreases availability of the entire solution. And I'm going to explain why in a few seconds. In order to improve that situation a little bit, you deploy those components in multiple redundant copies, right? So instead of like 1 domain controller, you deploy several of them. If one of them fails, then you can use the other one and stuff like that. Why does it work that way? Why redundancy is good, why the number of solution components is bad? So I cannot resist, due to Robert's introduction, right? I need to live up to the expectations, so I'm going to hit you with a very little bit of math here.
That's why we bring Boris, because he's the only one that understands the math. So.
But I hope by the end of this slide, this entire audience will be on my side as well. All right, so let's see. When we talk about availability, that term basically means that availability is measured in percentage, right? Everybody knows that, in those 9s, right? Number of 9s. Let's say, for example, you have some solution component, whatever that component is, for example, network or maybe storage. I don't care. And that component has availability of 90%. That technically means that there's a 10% probability that when you check if that component is available, it will be in the failed state, right? So it's the probability theory kind of concepts. The numbers are from there. So if you have a solution that has 2 components in it, what's the availability of the total solution if each component has availability of 90%? It's the basic theorem from the probability theory that if you need to find the probability of a combination of 2 events, you need to multiply probabilities for each event. 2 independent events, should I say. Independent is an important word here, right? In this case, the solution will fail when any of this component fails, right? So availability of a combination of those components will be the product of those availabilities. So 90% times 90%, the result is 81%. And 81, of course, is less than 90. So the more components you add to the solution, the smaller will be your overall result, the resulting availability. It's just a simple math, right? There's nothing beyond it. That's why the more complex your solution is, the worse it is. Complexity is evil. Now, let's look at the other dimension here, right? What if you have some specific component and you deploy 2 redundant copies of that component? Now the situation is kind of opposite. The solution will fail only if both of these components will fail. So we need component A, both of these copies, should fail. So we need copy 1 to fail and copy 2 to fail. What's the probability that the copy fails? It's 10% for each, right? 90% is availability, means 10%, that probability that it fails. So 10% times 10%, it's 1%. And correspondingly, availability would be 99%. So for the 2 redundant copies, the resulting availability of that component would be 99%. So that's good. That's why when you're adding redundant copies of the component, availability increases.
I think this points back to the middle bullet down here where it talks about failure domains. A failure domain is where we have multiple components that when any given one of those components fails, it can make the system fail. And this is where, in our example here, a SAN or a blade chassis, if you've got the blade chassis, you've got the backbone, the back plane of the blade chassis, you've got individual blades, you've got the power supply for the blade chassis. Any given one of those items fails, the entire chassis could go offline, right? Or just one of the servers or the entire chassis. That's what the first piece of math you did. The second piece of math is where we talk about 2 separate systems, so you have 2 failure domains. If one system fails, it doesn't bring the other system down. That's the second piece of math we did there. So when we talk about failure domains, that's what we mean when we say if you have a big failure domain, it impacts your availability.
And how that boils down into those probability statements is that you can multiply probabilities only for independent components, independent events. If you have the failure domain, it basically means that those components are no longer independent, right? And that's why this is bad. That's why the math will be broken in this case. So combining these 2 tendencies together, so if you have the solution that has many components and many redundant copies of each component, you can mathematically calculate availability of this complex system if you know individual availabilities for each component out there. It's just pure math. And you will end up with some number that hopefully you can bring up high and make it like 3 nines or 4 nines or whatever, but you understand even from those calculations that because our solutions are really complex, Exchange is not just one piece. You can easily probably build a list of like 10 components to that solution, right? It's very, very hard to reach the availability of the entire solution at the level of like 4 or 5 nines. And obviously, if somebody comes to you and says that they have the solution that has 100% availability for something, don't trust those guys. All right. So it was a long slide. I apologize for the math excursus, so no more. Now, how would you classically deploy Exchange, and what are the downsides of that model? So classical, traditional architecture model is the shared infrastructure. Shared infrastructure means that your IT department invests a lot of money into the solid enterprise class solution that delivers specific functionality. That could be, if you look at the slide, that could be a storage area network, for example. That could be arrays of blade servers. That could be a virtualized environment, right, when you have the huge hosts and they're running lots of virtual machines. Unfortunately, each of those concepts, each of those models introduces failure domains and introduces complexity. And it's very easy to understand, right? All of the blades and the blade server chassis, they rely still on the virtualized network interface that is created for them, and it's leveraging the actual physical network connection on the backplane, and they depend on the backplane itself, right? The disks in the SAN and the arrays on the SAN, they depend on the SAN controller and the SAN array, logic and mechanics and the circuit boards, on the SAN switches and all that jazz. SAN is a pretty complex concept by itself. So it is easy to understand that when we start analyzing kind of availability of this model, it introduces a lot of complexity that brings down the availability, and in order to compensate it, you need to deploy a lot of expensive redundant components there. So honestly, this is the old model. It's not so good for Exchange. That's not how the latest versions of Exchange were designed for. So what happens if you still deploy that and you still implement Exchange that way? Well, I'll bring you one example. This is the actual real email that we received from the customer, who very well might be right now in this room. It happened about a year ago. So
Was John in here? John Doe, raise your hand.
You can see, right? What I admire in this email, so we only replaced the names, obviously, and the name of the company to protect the innocent. What I like in this email is that phrase. You know that it's not our first or second or even third SAN failure, so don't worry, we'll handle it ourselves.
How many of you here, oh, our SAN never goes down? Yeah, I see a few hands. I swear I've talked to customers and they're like, don't worry, our SAN never goes down.
Until it does.
So if not that model, then what? What's the alternative? And the alternative is so-called building block architecture. So the idea is that each server is just a small brick in the wall. And the simpler you build and design that brick, the better. Ideally, all those bricks are completely independent, physically and logically isolated, so that if one of them goes down, you should have some sort of sophisticated software that lives on top of that and controls all that, that would automatically fail over whatever services this individual block was providing and activate those services on the other block in the solution, right? It's a pretty easy concept. It allows you to scale the solution pretty easily because you can build as many bricks in that wall as you need so that you could even build the Great Chinese Wall. And as the result, I guess that's what our data centers look like in the end. And it is simple. Again, simplicity is the key word here. So you're not trying to make individual bricks large or complex or well-performing. They must be simple. There's nothing that Microsoft invented here or Exchange. Again, at the very old times back then that Robert mentioned when I worked for Google and I saw the servers and the data centers there, I was really impressed. They were very basic, I would probably say even the word primitive servers. They didn't even have cases because case impairs ventilation. Why do you need it? They used the cheapest possible, like 40 gigabytes at the time, IDE drives. That's where Google kept the copy of the internet.
They didn't even build cases. I've seen pictures Boris showed. They Velcro the disks down.
Yeah.
And just they stripped it down to where it was the absolute bare minimum piece of hardware they could possibly have to perform the case, perform the duties they needed.
Bare minimum hardware, everything is integrated on the motherboard. The only two components outside of motherboard is the hard drive and the power supply. And both of them are just Velcroed to the, in the rack,
like
to the aluminum tray
right? Yeah.
within the rack. So if something bad happens with the server, you come in, you pull the server out, you unvelcro the disk, you throw it away, you connect the other disk, Velcro it back, push it back, press the reset button, done. Server automatically boots, installs the image of the OS, and starts participating in the cluster operations. It's a completely different model, right? It's not like replacing the SAN. Try to attach your SAN with the Velcro stripes.
Very small.
So that's what brings us, this concept, basically how they were realized. It brings us to the understanding of Exchange, PLA, and PA. So again, we already asked if you know the preferred architecture, and of course you do. So the new acronym here is PLA, which stands for the product line architecture. What is that? This is the Microsoft Consulting Services offering that basically guides you through the design and implementation of Exchange, following the very strict guidelines. In fact, we have a detailed kind of rule books that allow us to make design decisions for every independent individual point in the design where you need to choose and make a decision on something. And at the end of the day, it would be the solution which is built according to our guidance and best practices. So it is using preferred architecture as the model, and it acts as a practical implementation. So maybe you could think of the preferred architecture as the theoretical model that shows you how you should be doing things, and PLA as the practical recipe of how you should be doing that. So with this, these are our concepts and principles. So back to Adrian for a moment.
Boris? No maths in this section, I don't think. Not for me, anyway. So now you know about the preferred architecture and how to do it, but that's just theory, right? That's not real life. In your environment, you've got challenges, and you've got someone saying, but this is our corporate standard. We've already invested in the SAN. We've done this. So this next section is about challenging our design. And for this, we've come up with a bit of role play. So I'm going to pretend to be a customer, one of you, and I've not had any Kool-Aid for a few weeks, so I should be good. And I'm going to challenge these design points with these guys, and they're going to come back and hopefully convince you that our preferred architecture is the right thing to do. So there's two ways you can do the design challenge or challenge these designs. This is one way.
So I think this is a screen we mocked up. We'd really like to see the Exchange install package say this. You know, it looks like you're not doing the preferred architecture.
So look out for CU4,
maybe you should
guys.
try it again, right?
CU4 is coming.
That's what you hopefully see in CU4, yes. Exchange will check on you.
We're working with Ross and the team trying to get them to get this into the product.
Right, but the other way is with knowledge, right? So I'm the head of infrastructure of Contoso, and I'm gonna challenge these guys. So we've kind of thought about the top 3 design challenges, and this came about from the internal discussions we have in Microsoft, and these are the ones that are raised day in, day out on the DLs internally. So number 1, storage. That is probably the biggest design challenge that customers have.
So how many of you here deploy your Exchange on a SAN today? It's overwhelmingly, right? It's still the way people want to do it.
Yeah. So let's go with storage. So as I said, I'm head of infrastructure, and my Exchange guy is saying this new preferred architecture thing says no SAN, DAS disks. DAS, who uses DAS anymore, right? This is kind of going back. This is a regression for us, right? So everything's on the SAN. It's our corporate standard. Mr. Microsoft, what's that all about?
So first of all, we need to understand that when you design the storage solution for Exchange, there are several variables there. And the most important criteria that you usually meet with the storage design are complexity of the solution, performance of that solution, and redundancy of that solution. And those 3 are completely independent dimensions. So technically, any storage design that you end up with is like one point in that 3-dimensional space, right? What are the variables here? First, the complexity. Obviously, that's the dilemma between SAN versus DAS. And there are lots of usual misconceptions here. SAN by itself, for example, is not faster than DAS. The speed of the disk operation is determined by the disks, not by how you combine the solution together.
But my SAN vendor says it's got like a gazillion IOPS, and Exchange needs IOPS, right? So
10 gazillion IOPS is definitely a decent amount. The only question is, why would Exchange need those IOPS? And that's where we start understanding the difference between different types of drives. Since your SAN gives you gazillions of IOPS, most likely you're using the fiber channel disks there, or at least
yeah,
that
of
for
course,
starter,
we
right?
got the best.
Nice. How much they cost you?
The most amount of money. We won't talk money.
The best, right? Yeah.
It's
okay.
expensive.
The best drives in the world, yeah. So typical fiber channel drive, or even the SAS drive, if it's the fast 2.inch 15,000 RPM drive, gives you about 230 IOPS. Nice, right? 230, that's the good number. If you take some slow, cheap disk that you can buy on like Newegg, it would deliver you about 70 IOPS. Yeah, I understand the difference. Yeah, definitely the fiber channel drives are better. Now the point is, Exchange database needs about 10 or maybe 15. If you complete the Exchange storage calculator and you see what are the requirements for the performance, that's what you need. Do you need the disk with 230 IOPS when you really need 10? Or would you be better with the disk that gives you 70 and costs 1/4 of that?
Okay.
Now, you got to remember, in Exchange, as we went from Exchange 2007 to 2010, we reduced the number of IOPS necessary by 70%. When we went from 2010 to 2013, we reduced it by 70% again. There was not nearly as radical a reduction going from 2016. I've seen numbers, I think 30%?
It's about 30%.
About 30% more reduction in IOPS. But still, we've reduced, time and time again, we've reduced that number of IOPS we need. And this goes back to what Boris was showing earlier about in 2003, we had these huge IOPS numbers we needed. In 2013, 2016, the numbers are nowhere near as big as they used to be.
In fact, we honestly believe that the next version of Exchange on premises will give IOPS back to the storage.
But when you combine this huge reduction in IOPS that we have now with the need of our users to have large mailboxes, that means that these big, cheap drives you can go buy that give you enough IOPS allow you to do what you need to do. And that's why we come in with this direct attached storage, no RAID solution, is we believe we can give you the service you need. And that's exactly what we do in Office 365.
And
That storage is not rated in Office 365.
And that's a good point, because remember I said that in the modern Exchange solutions, the software powers it. So we control that replication between the databases now in the software level, within the database availability groups. So technically, you do not need RAID anymore. No need for that disk redundancy. What's the purpose of RAID? Replicate the data that is on the disk, right? So that if one disk is failed, then the other disk would kick in. But we do that from the application level now. All your databases would exist in multiple copies, so there's no need for RAID
Okay. So I
anymore
don't
as well.
need the IOPS.
That means the sweet spot for Exchange is really as shown in this diagram. Your choice between SAN versus DAS, RAID versus JBOD, and different types of drives, that's where we see the best fit for Exchange based on how Exchange was designed.
Okay. So in terms of money, money's not an issue. We're rich.
Okay, so we'll charge you more as your consultant.
Does anybody share that sentiment here? Please raise your hands who are completely rich and don't count money at all for your solutions. I don't see them. So no CIOs in that room? Okay. So money is always a concern, of course. And your design, it's very important how much it costs. One of these 4 pillars, remember that we listed as the design principles? The cost. Now, the funny thing is, this table, which is kind of hard to read, but we will give you time, and then I hope you will download the deck and look at it later. It's the actual real numbers that show the calculations for the typical Exchange design for 60 databases and 12 servers across 2 sites, right? And what happens if you use the already existing SAN arrays and just populate them with the storage, with the disks, using that hypothetical but very easy to understand what we're talking about SAN model with RAID DP parity group used for the drives and 1.2 terabyte drives used in there, versus if you deploy Exchange on the DAS and use the storage enclosures or just internal disks in the server itself, if it has enough drive slots. So all the numbers here are kind of real. We validated them specifically because time goes, right? So the price kind of goes up and down. So they are up to date, and you can see that actually the result is very interesting. So your SAN would be actually about 3 times more expensive than the DAS solution, even if you assume that you already have SAN infrastructure. So there are no expenses here, if you look at the table, for SAN switches and fiber channels and stuff like that. This is all already supposed to be there.
Okay, so I could save some money. That's never bad, is it? So talk to me about RAID. You just said that you don't need RAID anymore. Everyone knows Exchange needs RAID. Tell me about that. I'm not buying this no RAID. DAS with no RAID? That's madness.
Yeah, I remember first time I heard that we were doing a class and one of the guys comes in and says, so what would you do if I told you that the next version of Exchange, we're going to say don't run it with RAID? And those of us at Microsoft, we were just like, that's insane. Why would you ever do that? But I mean, I think we've got a good story here.
So again, the copies, the database copies that we have in database availability groups provide redundancy and functionality which is equivalent to what RAID is supposed to accomplish. The difference is that the RAID is sort of hardware-powered solution. Well, it's not technically hardware, right? It's a firmware that is running on the RAID controller, but you understand what I mean, right? And our Exchange replication is the high-level solution that is implemented within Exchange, within the replication service. So you get technically the same functionality, but solution that is implemented at the application level, it is smarter by definition, right? It's application aware. Exchange understands what it replicates. It's not just zeros and ones on the disk platters. It's the transaction logs. And Exchange, for example, understands that when it replicates transaction logs, it does not need to replicate database file itself, because transaction logs, you can just replay them into the database, and that's how you would sync up between the database copies. So you would not need actually to replicate the entire data on the drives, but only that portion that refers to transaction logs. It's like more than 50% reduction in the disk traffic here, right? Now, if you deploy our model with the database replication, you would also deploy additional copies of the servers. So that gives you extra redundancy for other components, not just the disks, but the software that is running on the servers, the client access components, the transport components, and all that jazz. So you get the redundancy for the entire solution, not just for the disks. So these 3 diagrams are showing you how you gradually move your understanding from the design that is totally okay, but we don't consider it good, and this design is using 4 disks with 2 database copies and 2 servers. You gradually evolve into the solution which uses the same 4 disks, but now you have 4 database copies and much better redundancy for the solution.
And we talk about in the first model, your servers are probably going to be very redundant. They're going to have redundant power supplies, redundant NICs, redundant everything in there, right? Hot plug memory, all that kind of stuff. Enterprise class machines. When we get into that best down at the bottom, we're also talking about commodity servers, inexpensive servers, cheap disks, cheap servers. One of them fails, we just accept the fact, right? And so we think we bring that cost model down when we do this with more servers than you would have with the more enterprise class servers in what we've labeled bad here.
Okay, so speaking of cost, you kind of tell everyone to have these massive mailboxes and disk is cheap, and blah, blah, blah. But actually, you deploy a big mailbox, and that disk is just wasted. Right? No one's got a 50 gig mailbox at the start. So I plan for, I don't know, 5-year growth. But actually, right now, everyone's got a 2 gig mailbox. So I've now got, I don't know, maybe 100 terabytes of disk just sat there wasted. That's wasteful, right?
That makes total sense. Yes, I understand your concern. You don't want to pay for the full storage for your solution that you plan for probably 5 years at least, paying for all that storage upfront. Totally understand that. So our recommendation, which is still to provision all the necessary storage upfront, let me try to explain why. What are the actual reasons to that? Well, first of all, we already passed that stage when we mentioned that the modern disks are really inexpensive, and there are large disks out there, right? You can buy 8 terabyte drives today. It's the mainstream, and 10 terabytes and even larger are already also available. So you could deploy a lot of storage per server. As a matter of fact,
but it's not wasted, right? So on my SAN, I can
right,
thin
exactly.
provision.
So I mean, it's still affordable right now. I'm working right now with a big customer who is deploying the enormous amounts of storage per server. Technically, the storage enclosure there is capable of hosting 720 terabytes, right? So that's quite impressive. But like you say, it's sort of wasted. So what are our options here? One option, and this is the risk that many customers unfortunately accept and then end up with problems, is called thin provisioning. That means, okay, so my mailboxes today are only like 1 gigabyte. I'm referring to the numbers on this diagram. Today it's only 1 gigabyte. Yeah, it's growing, but today it's only 1 gigabyte. So what if I just deploy 2 gigabytes of storage, of actual physical storage per mailbox? Yeah, we still tell the users that we upgraded them to the new shiny, bright new Exchange model, and they now have 10 gigabyte mailboxes. But we know between us, right, that they're not really using 10 gigabytes. They're only using 1. So we will give them physically only 2, and life is good, right? Nobody will know. At the time when their mailboxes will grow, according to that third diagram, we will deploy more storage, and they will get more and more. Problem is, can you really deploy additional storage that fast when the operational changes require that? Do you have the operational excellency and the processes in place, including bureaucratic stuff like procurement and shipping and deployment that allows you to follow that model? Unfortunately, that's very doubtful. And we had seen in numerous situations in the experience of our support group that it is practically never the case. So the operational challenge for using thin provisioning models is huge. You can definitely go with some intermediate kind of compromise model and say, okay, we will still provision less storage to Exchange, less physical storage. We will provision only 2 gigabytes, but we will honestly tell users that we don't give them 10 gigabyte mailboxes right away. We only give them 2 gigabyte mailboxes. And that's how we configure Exchange. We configure the quota limit on the mailboxes to be only 2 gigabytes. And then we will change it next year when we add more storage. And then we will change it next year when we add yet more storage. Now there's no risk now for Exchange running out of storage suddenly, right? If there's some mailstorm or somebody starts sending the multiple copies of their favorite video clip from YouTube, right, to all the teammates. There's no risk really, but still there's significant operational challenge in doing those design changes every year. So when you're adding more storage to the servers, you would need to most likely redo your database layout, reconfigure the databases, moving mailboxes around a lot. So that's yet additional complexity and additional challenges. Yeah. And again, complexity, I said that word again, right?
That's what I was going to jump right in there.
Complexity is evil.
If you've ever seen me speak before, one of the things I always talk about is the reduction of complexity. Just keep it simple. The more simple you can make it, the better off you are. Any complexity you add to a system is adding risk to your project. Complexity in your operations model is just the same. We can talk about complexity of the servers, reducing complexity of servers, and that's great. But reducing complexity in your operations is also essential. And if you introduce these complexities Boris is talking about and how you manage your storage, all you're doing is you're driving up the complexity of how your people have to manage those servers, and that introduces risk in them doing something wrong or something not going the way they expected it to and causing problems while you're doing your management of those.
Right, fair enough. So it's probably a good idea to just buy all the disk, put it in, and leave it.
And it will, you look at it and you can't make the argument that by buying less disks you're spending, you're not gonna save money. But what you have to do is if you look at, with these big cheap disks we're talking about buying, you gotta look at the dollar figure of what that's gonna cost you versus what that operational complexity is gonna bring in operational expenses. So you're balancing out CapEx and OpEx there, and you've gotta look at that and make sure that it meets what you need. But our belief is that buying the disks up front is actually in the long run cheaper than trying to do this complex management of disks in the long run.
And if you're curious where you can get all this inexpensive disks and stuff, I can send you a link to Newegg.
Yeah, send me a link. So if I'm buying all these disks, that means my enclosures are going to be big, my servers are going to be big, I'm going to be taking up a lot of rack space.
So this is a good question. So even given that we understand and accept all these principles of how we want to organize our storage, we still want to deliver those large mailboxes. Given that and the concept of using DAS, which is typically the small disk enclosure, together, how could we really build the good, reliable server platform? So what you see on the slide is the typical Exchange disk layout and the hardware platform that Ross describes in the preferred architecture article, and this is what we would normally recommend to the customers. So the commodity class 2U server, which has today, depending on the model, you can get like from 12 to 16 drive slots. And those drive slots that you want in the server, they are 3.5-inch drive slots for the large drives because of capacity. Remember, you need capacity. You're not hunting the performance of those disks. You're hunting for capacity. Out of this, let's say, 12 drives in the server, you would use 2 of them in the RAID 1 mirror because Exchange replication is great, but Exchange replication applies to the databases only, not to the operating system. So you would still want to protect that. So 2 RAID 1 group disks for the operating system and for Exchange bits. 1 disk you keep within that same server as the hot spare, and the remaining 9 drives are used for the database, for the Exchange databases. Now, those disks are big, right? So you can buy 8 terabyte drives. We don't want you to deploy 8 terabyte Exchange databases. That's a lot. It's just hard to manage these large files, right? Our recommended maximum for Exchange databases, as you know, is 2 terabytes. But you can deploy 4 databases on a single disk. And if you use the proper, nicely designed database layout, you would spread your active database instances evenly across these disks and across these servers so that each individual disk under normal operating conditions would only have 1 active copy of some database and 3 passive copies. And that would apply to any disk on the server. Now, the last point here is that you would have the hot spare right there available. So even if one of these disks fails,
Well,
you could easily
if the
replace
disk
it.
fails,
It's win.
I noticed how you used the picture of the disk with the nice green lights on. Within a few months, those lights are going to be amber, and someone's going to have to go around changing those disks, right?
That is true.
Well,
I haven't got a process for that.
so there's always going to be process change when you change this kind of business model, what we're deploying here. One of the things we always talked about was, do you have high school kids that come in and work for the summer, or they, interns or something like that, the people that are just starting to learn. Get them an A+ certification, get them a low-level IT certification, and then part of what they do on a daily, weekly basis, they go around, they replace the disks that have amber lights, right? Automatic, what Boris was talking about is automatically we've got this hot spare. Exchange knows how to pull in the hot spare, reseed the databases on that disk, and bring it back in automatically so that when you're swapping out these disks, it just becomes a hot spare again.
So
When the
Robert,
disk fails, what happens? It swaps it in,
It's swap.
formats it.
yes,
Yes.
Robert mentioned this great new feature, Well, it's kind of relatively new, but let me ask that question. So how many of you in the audience are running Exchange 2010? Okay, it's about half, maybe more. And Exchange 2013, 2016, just to make sure that you're not sleeping? Okay, the other part of the audience. So that's actually significantly less. Okay, so I would say probably about 70-30 is what I'm seeing from the hands, right? So that feature is important for you because in Exchange 2013, 2016, there is auto-reseed feature, which allows Exchange to automatically invoke the hot spare disk that you have in the server when it detects that one of the active disks hosting database copies failed. It would invoke the hot spare disk, automatically format it, seed the database copies that were on the failed disk from the other servers, and bring it into the operations. So you would restore the redundancy level for all the databases that were on that disk. Isn't that similar, at least conceptually, to how RAID arrays rebuild themselves, right? You don't need to sit down in the server and watch how the server does its magic for the RAID arrays. Same here. Exchange will does it automatically for you. It would use that auto-reseed feature. So
And you don't necessarily need a master's degree to walk up and down the aisles and change out those amber lights.
No, but
Right.
we need a process, right? So I haven't got
You
one
do.
at the moment.
And that's the thing. Anytime you bring something new in, we're going to have to work on the processes, right? So it doesn't matter how you're going from Exchange 2010 to 2016. We're going to have processes we need to work on. Your backups may be different. The virus scanning may be different. There's a lot of things that could be different. So we're going to have to work on processes. This is just one of them we'll have to work with you on.
Okay. And RBOD? I thought it was JBOD. You guys are just making stuff up now.
I think Boris made that one up, actually.
yeah, so this is definitely not the widely used term.
It's Russian.
But
bunch
what
of
it's,
disks.
no, it's, yeah. It's the raided bunch of disks, and this is the term that storage guys are using. So what that means actually is that a lot of customers are thinking that when we say JBOD, we mean really just a bunch of drives, HBA card that passes all the signals from these disks directly to Exchange, and that's it. Unfortunately, no. You do need the RAID controller, and the reason you need the RAID controller is the cache on this RAID controller. Yeah, you're going to tell me, what the heck, why do I need some cache? Can't I use credit cards? We live in the 21st century, after all. So the cache is still a must. And the reason for that, the main reason for that, is that the cache gives you the right performance. If you look at our storage configuration recommendations, you would see that we would recommend configuring RAID controller and dedicate the cache on it for 100% write operations if you use the DAS storage. That's because, yes, we do a lot of work and we put a lot of efforts into decreasing the number of IOPS that Exchange requires, but it's still not free. And Exchange databases, by their nature, they are random disk operations. Because you have thousands of users connected to the servers, you cannot predict what instruction will come in the next millisecond to the Exchange server, right? Which mailbox it should access and what operation it should do. So it's all random disk operations. And write cache allows you to improve performance here and meet even those reduced Exchange requirements. To understand better how dramatic is the effect of having the cache and the RAID controller, these are the real numbers that you see on the slide that we did in one of the very big projects we worked on. And actually, as a matter of fact, I had similar numbers communicated from some of our consultants working on a different project in a different country, which show that the modern drives, good modern nearline SAS drives, 70 to 100 RPM, can deliver amazing performance from this disk, up to 90 IOPS per disk. Even though if you look under the hood of the storage calculator, we still calculate performance assuming no more than 55 out of the SATA disk. In reality, you could get up to 90 today. So the vendors are improving definitely. But only if you use the controller and the cache on the controller. If you remove the controller and just let the data flow in, you would end up with a miserable three or four, seriously, IOPS per disk.
And now remember what Boris said earlier. Databases are starting to need 10, maybe 15 IOPS per database. And we're putting 4 on a disk. So that's 40 to 60 IOPS. See, I'm doing math too.
And that
Right in my
means-
head, I'm doing math there.
That means
40
that
to 60 IOPS you need. And if all you're getting is 3 to 4, we call that a fail.
And that means that your jet stress, unfortunately, will fail miserably when you test your storage.
Yeah,
storage.
Boris and I,
Stress,
Boris
what's
and I,
that? What's-
So that's important.
yeah, Boris and I had this on one of our customers we were on.
Now,
recently.
with that, there's an interesting detail, one other interesting detail I wanted to focus on, and that's where the screenshot comes from. So some of the RAID controllers have the feature that they call pinned cache. So that basically means if one of the drive fails, one of the virtual volumes fails, the controller just takes the entire content of cache and the controller freezes it because controller thinks that there might be loss of data, so it tries to preserve as much as it can, freezes it, and that means it automatically switches all the other disks from the write back mode into the write through mode, which technically means no using cache. So your performance immediately goes down. And we don't need that because you do have those redundant copies of this databases, of this disk. If you have a failed disk within the Exchange server, the heck with it. You have 3 other copies out there. They will kick in within seconds and you will continue delivering services to your users. And this disk that failed, AutoReceipt will take care of it, right? It will invoke the hot spare, it will reformat, do its magic and stuff like that. So you don't need that pin cache event. So be careful about it.
Okay, you kind of convinced me. My SAN guy's not going to be happy. Exchange is a big consumer.
Well, we're not telling you to take your SAN out. Use the SAN
What am I
where it's
supposed to do,
needed.
sell
There
it
are
on
some
eBay
great
or
uses
something?
for SANs, right? So I'm not telling you throw it out, right? You always need more storage for your SharePoint or file shares or something along those lines. Databases need more IOPS for your SQL Server databases or Oracle databases. Use the SAN where it matters. Right? You don't need one tool in your toolbox. You need multiple tools, and that's just one of your tools, and Exchange doesn't need that tool.
Okay.
But if you are greedy and you don't want to share with your SharePoint friends, just imagine what kind of an offsite you could have for your team when you sell that SAN on eBay.
Party.
Okay, let's move on. The next one, high availability. What's the deal here? What's the kind of philosophy around?
You know, we have a joke about it. We're saying that the definition of the optimist, it's the person who wears the pants without the belt and without suspenders. And the definition of the pessimist is the guy who wears the pants with both belt and suspenders. 'Cause that provides you this extra redundancy that you need in case something happens to your pants. That's what high availability is about, right? You want to be safe. You want to make sure that nothing happens.
I'd leave out the fashion tips. I think if I were you, stick to the maths. So, okay, so we've got 3 data centers, right? Proud owner of 3 data centers, and so we've got New York, Seattle, and these 2 replicate, and we've got another one in London, and that's our kind of DR site. Everything gets replicated to London for in the event of a an asteroid hitting the US or something, right? So he's my guy's saying you can't stretch your cluster, your DAG between 3 sites. 3 sites is bad, and he says you should stick to 2 sites. 2 sites is good. 3 is better than 2, mostly.
50% better.
So what's the deal?
So first of all, congratulations to you with having 3 data centers.
Thank you.
Damn, I cannot afford a single house in Silicon Valley, and you're talking about 3 data centers.
It's really big as well.
So the point here is that complexity again. So when you start thinking about how Exchange operates within the database availability group, within the DAG, everybody knows that this is based on failover clustering feature, right? Failover clustering is very sensitive to the networks you have and the communications it has on these networks. Basically, every node in the cluster must be able to communicate with all other nodes in the cluster. They need to be in full agreement. Like our entire nation in America must be in full agreement, considering who's going to be the next president,
Yeah.
right? So when
Don't go
you
there.
have 3 sites, I totally trust that your local area network within the site is solid and reliable. So the servers within the site are in full agreement with each other. But what happens if, for example, like on this diagram, your WAN link between Seattle and New York fails? So the Seattle servers are like, oh, we don't see those New York brothers anymore. There must have been some terrible accident. New York doesn't exist anymore. Hey, London, we're now together, just you and I, right? So let's form a cluster and let's continue functioning. New York guys on the other side, they say, oh, looks like there's no Seattle anymore. It's probably Yellowstone volcano eruption or something. It's no longer there. So London, it's just you and I now. Let's form a cluster and continue functioning. And London sits in between and like, who am I going to marry? This girl or that girl? Who am I going to go with? And there's no polygamy in the exchange world. You need to choose, right? So London will start choosing, and it will say, okay, you evict your nodes from the cluster. And the exchange servers will say, I'm going down. My databases are going down. They would fail over to the other servers, and you don't understand what's happening. Technically, you can still ping. You can kind of go across all the servers out there. So if you want to get into more details about the complexity of this process, there's a link at the bottom of the slide. I would highly advise to read that. It's actually a link from the failover clustering perspective. It's not exchange specific, right? So it equally applies to any technologies that use that feature. But bottom line is, do not multiply complexity of your DAG. 2 sites is where you have things logically independent and simple, right? How many network links are there, external network links are there between 2 sites? Just 2 sites? How many links are there? 1, right? When you have 3 sites, look at the diagram, hint. How many links you see there? 3. 3 is bigger than 1, right?
Yes.
About 3 times bigger.
So the management of that
Don't go
is
there.
3 times bigger, right? The management of that network is 3 times bigger.
And
So-
your risks are 3 times higher.
All right, so that's fine. So unfortunately, I can't sell my data center on eBay like I can my SANs. What am I supposed to do with this data center? If you think I'm proud, you should see my CIO. He's got pictures of it on the wall.
Data centers are good. They're valuable assets. And from the real estate consideration, they're only growing. So yeah, keep them, of course. But use your sites wisely. Now, how could you use the 3 data centers if you really want them? Well, first question to ask is, how are your users distributed between those 3 data centers? Does it make a difference for you? Is it important where the users are connecting to which side? Maybe yes, maybe no. But in either case, if you want to reach to some nice symmetric design, you could deploy, for example, 3 DAGs. Each DAG will cross 2 data centers, so that you will have 3 DAGs forming like a triangle there, and you distribute your users evenly across these 3 DAGs, and your replication is working between each pair of the data centers. Here's the nice and symmetric design, and you can use all 3 data centers like you wanted.
Okay, but 1 namespace. That kind of says to me that I'm going to have all sorts of proxying traffic going across the WAN.
That's certainly a consideration as we start talking about as we're going into here, the bound and unbound models. If you want to have 1 namespace, one of the things we had when we went to Exchange 2013 is a lot of our customers on 2010 said, we want automatic data center failover. I don't want to have to go through this process. A lot of you raised your hands when you said who's on Exchange 2010. You have a process for how you fail over data centers. It's a very manual process for that site resilience. Exchange 2013, we brought in a new capability where we can have automatic data center failovers. The problem there is that you have to roll in the fact that you're going to have cross data center traffic that you wouldn't have in what we call the bound model. In the bound model, I say these users that are on the West Coast use the West Coast data center.
That's what we do now.
Users on the East Coast use the East Coast data center, and the users in London use the London data center, right? So if you do that, you can control that WAN traffic to some level. If you don't have that, if you have this unbound model, you're going to have users that are going across, because you may have users in the UK that are using your New York data center. And it's something to take into consideration when you go with that.
And those of you who are using Exchange 2010, you know that this bound service model that Robert described is actually our preferred guidance for Exchange 2010. You would keep your namespaces local, one namespace per data center, and that's how you control where your users are connecting to. But starting with Exchange 2013, our preferred model became unbound because it allows you to use single unified namespace. It's easier. Why? What's the difference? What allowed us, when we switched from 2010 to 2013, what allowed us to switch to the unbound model and actually have it as the preferred one? The key to understanding this is to realize that in Exchange 2010, client access server and the mailbox server, they talk over RPC. You know that the users don't connect directly to their mailboxes, right? Users connect to the client access server component. And then client access server component proxies the user connection back to the mailbox. So that communication in 2010 goes over RPC. So you don't want your client access server and your mailbox server sit across the WAN link, because RPC does not like WAN link. RPC is technology that is pretty sensitive to latency, and it wants to be confined within the data center. But in Exchange 2013 and further, the communication between client access server and mailbox server is HTTPS. So those roles are decoupled. So HTTPS is OK with traversing the WAN links. So that allows you to have that single namespace and spread your mailboxes regardless of where the actual users are located. But the downside, of course, is that there will be more traffic being proxied between the data center.
So the question is, should I worry about that extra traffic? Because most of that traffic is going to be replication, right? So
that's exactly right.
How much more is that going to add? And is it enough for me to worry? That's the question.
So when you design your site resilience for Exchange 2013-2016, in the storage calculator, one of the tabs allows you to project how much bandwidth you would need for the database replication. And that will be the lion's share of this bandwidth that you need between the data centers. On top of that, the traffic from proxying the client connections is really minuscule. You can still estimate it using the client network bandwidth calculator and see how much basically traffic your users generate when they connect to Exchange servers. Then in the symmetric two data centers model, you can expect that about 50% of that traffic will be proxied, and that will give you the numbers for the estimate. But you will see that these numbers are significantly less than what you need for the replication. So if you have a proper pipe between the data centers that accommodates your Exchange replication traffic, most likely you should be OK with the unbound model.
OK, so that's client access. But that's just where the clients connect. What about the actual databases? How do I now have to load balance my databases around, so I need to think about, OK, I put some on this server, some on that server, some on that server.
And that's where the storage calculator helps you again. Right, so there's a magical distribution tab there in the storage calculator that provides you the database copy layout. And this is, quite honestly, this is probably the most sophisticated portion of the Exchange design. So typically, if you don't know anything about it and somebody asks you, how would you distribute your database copies across servers, you would probably scratch your head and say something, OK, why don't I put my first 10 databases active copies on server 1 and passive copies on server 2, and then I take the other 10 databases and put them on servers 3 and 4 and stuff like that. That's not good, because if one of your servers fails, let's say that first server fails, all these 10 databases that were having active copies will activate their second copy, but you placed all of them on server 2. That means server 2 will now carry double load, and the other servers will be just unaware of anything happening and just keep functioning as they did before. You will have the uneven load on the servers. So the algorithm that we use in the database copy layout, and if you're interested in where this algorithm came from and how that works, there's a link here in the article, in the slide. You can go to that article and read through it. It ensures that even in the failover scenarios, you would still have the even distribution of the database copies. Like on the slide, you have 60 databases distributed across 6 servers. Each server is hosting 10 active instances of the databases. One of the servers fails, the database copies are distributed in such a way that 5 remaining servers now will host 12 active instances each. Total is still 60. 5 times 12 is still 60. If the second server fails, I should say another server fails, it doesn't really matter which one, right? You would now have 4 remaining servers there, and each of them will be hosting 15 active database instances. 4 times 15 is still 60. I'm sorry, I seem to be back into math now.
You can't help it. Okay, it makes sense. I'll be honest, I'm still not convinced about this 4 copies. It still seems a bit overkill. I've got backups, so I do a full backup every night. I keep my dailies for a week, weeklies for a month, monthlies for a year. Yearlies are just kept. Why do I need 4 copies?
Let me ask you right away. So how frequently do you restore those copies just to test that they were backed up properly? Okay, and what media do you use to store all these copies for in the long term? You probably use the tapes or something.
Well,
like
at the
that.
moment it's LTO6, but I think we got some LTO5s, LTO4s, LTO3s. I think we got some DLTs.
And you've got
Last
drives
time-
for each one of those, so you can test any given one to bring them back.
Last time I saw this, what you mentioned, I cannot even repeat these acronyms, but I remember that I have seen them in the Computer History Museum in Silicon Valley. So when you will need this data from those copies, probably 3 years from now for some litigation purposes or something, do you have like a device where you would load those tapes into and restore the data?
I have to ask my
Or you would need to go back to Computer History Museum and ask them for rental?
Ask them to borrow.
So that's the point. And if you think about the backup copy, what's the difference? It's a copy of your database, right? It's kind of converted into some backup format and stored on some weird media that you don't know what to do with. How about just having additional copy of your Exchange database, which you can mount in seconds, and it has all this information in it. So instead of having 2 servers with 2 copies plus the backup, which would require you to have at least, like 7 disk volumes, just deploy 4 servers with 4 database copies and no backups. And you would actually decrease your storage requirements because you will also need no RAID.
And everybody knows that in Office 365, we do this Exchange native data protection. There are no point-in-time backups made of the databases, right? So that's the way Office 365 is done.
Okay. Lastly, virtualization.
Yeah, don't.
The V word.
Yeah, just look at that brilliant screenshot. We just love it. It's the virtual machine that is running inside the virtual machine, inside the virtual machine, inside the virtual machine. And you can see the screenshot of all of them.
You just blew my
Yes,
mind.
you can build your lab like that if you're really a big fan of the process. But the short of it, don't do it. Why?
Look, the point is, it's a corporate standard, right? Our corporate policy is to virtualize everything. We're kind of going green, and we're reducing our footprint. Virtualization is really cool.
The thing is that corporate standard is kind of, I totally understand the driving factor, but it's a little bit dangerous word, right? Imagine that all of the houses of your city would be absolutely identical 2-story houses with 3 bedrooms and 1 bathroom. Would everybody be happy? Different technologies, different workflows, they have different requirements. They have different needs. What could be good for one technology not necessarily is good for the other. And the key to understand here is, but with all this sophistication that we have in Exchange, with all this database replication, automatic failovers, auto-reseed, unbound models, client access, balancing, proxying of connections between the servers, it is smart. It is doing all the things, all these availability benefits that probably you would be deploying virtualization for. Just think about it for a moment. Like back a long time ago when we had separately client access row and mailbox row, you could put both of them on the virtual machines and host those virtual machines on the same host. But what's the point? Why don't you just deploy one multi-role server, which have both CAS and mailbox roles together? So when we understood it, finally, and realized, we ended up with, as you know, like in Exchange 2016, you cannot even separate those roles anymore. Just CAS and mailbox are always together because there are really no reasons to separate the roles. Now, if you have, let's say, multiple Exchange servers that you're hosting on the same physical server, that's even more ridiculous because what is it? You are splitting all the client requests into 3 virtual machines just to have them share the same physical resources again? What's the point of that load balancing?
Okay. Seems a bit crazy.
And it brings complexity. So I guess that's another email from the customer or another description of something that happened, right? Virtualization is just a brilliant example of complexity that you bring into design with no apparent really benefits.
Okay, so what am I supposed to do with these massive servers I've got? Vendors are selling 500 gig and 48 core. You guys are like 96 gig, 24 core. That's like 5 years ago.
So this is something we've really heard, and we've heard it loud and clear, and we really push the product group on this. We all work with customers on a day-to-day basis, and we hear from our customers they want to use these bigger servers. We need to be able to be testing that, and we're pushing the product group on that. There's just nothing to share at this time on that. We really want them to be supporting the larger mailbox or the larger memory models and more cores. It's people just aren't buying these little bitty servers now. So it's really something we're hearing about.
If you need to know more about the details of where these limitations are coming from and why and kind of all these technical things, go attend the session, I think it's tomorrow, of Nazir Ali on the performance troubleshooting of the Exchange servers. You will get that secret knowledge. But the bottom line is, don't scale up. That's the message. Don't use heavyweight, big Exchange servers out there. Better deploy many commodity class small servers. If you already have those big servers, if you don't want to sell them on eBay like you did with your SAN, well, that's probably the only reason to virtualize.
You say don't virtualize, but then in Azure, you can virtualize, and that's supported.
Yeah, that's
and then
it's
I'm in the
supported.
cloud.
So there's a lot of supported scenarios. That doesn't mean it's necessarily our most recommended scenario. And Azure is going to be an expensive way to deploy Exchange. It just is.
I told you we're rich. Right?
And another key concept to understand it here is that Azure is not Exchange in the cloud. Exchange in the cloud is Office 365. Office 365 is not Azure. It's not the same. Azure is infrastructure as a service. It just means you will get your machines hosted in the cloud. You still have to manage them. You would still need to configure your Exchange servers, configure the DAGs, deploy all that stuff. You would need all the components there, domain controllers, everything. Office 365 is software as a service. You don't manage the servers in the Office 365. Microsoft does it for you. There's a big difference.
Okay. Okay, you've convinced me, Mr. Microsoft.
Yay.
I'm no longer a customer now. Is that all right?
That's fine.
Welcome to the family.
It felt good for a bit, actually, giving you a kicking. So this next section, why we think you should seriously consider Office 365.
I'll do it.
And Robert's going to...
Typically, they give me 3 to 5 minutes to do this, which is supposed to be 10, and I've got 2. So I'm going to go through some of this quick. Just so you don't have to worry about all this stuff we said, just go to Office 365, because that's the way we do it in the cloud, okay? So we have to remember here, everything's about people, process, and technology. Most of what we've been talking about today has been about the technology. We have to remember your people and processes, right? Office 365 really kind of drives what our PA guidance is. Everything we've learned, we learn from our customers through our PFEs, through our consultants, as well as learning what they do in Office 365. Why can't you do what we say in the PA or PLA? We hear this all the time. This is our corporate standard. A lot of these are written kind of like it would be a Microsoft consultant or one of the partner consultants that we work with all the time. But we hear this, that's our corporate standard. It was what Adrian was saying earlier. We virtualize everything. That's something we hear. We think you have to change that thinking, right? If the only tool you have is a hammer, every problem you have is going to look like a nail, right? But I firmly believe that some problems are going to be a screw. And as all you have is a hammer, that doesn't make it right. So we need to help the CIOs understand that there's multiple tools in the toolbox. Maybe we don't need to virtualize that. Maybe we don't need it on the SAN. So if you need help at that level, you can talk to your Microsoft consultants, you can talk to your partner consultants. We can try to get to that right level to have those discussions with the CIOs, right? Even if you're just one of the guys that's deploying this on the ground, the guys or gals, we can help you have those discussions with the powers that be to make changes in the way things are thought about. And are you getting the right advice? We know, we have a word inside Microsoft, we call it co-opetition. We cooperate very closely with our partners, even though we compete with them. Some of our guidance is not what our partners would be telling you, right? The virtualization guys are going to tell you virtualization's great. The SAN guys are going to tell you SAN's great. We're going to tell you you don't need either one of them for Exchange. Our guidance, we write our guidance. We believe we have the right guidance for Exchange, right? We are Microsoft. We do believe we have the right guidance for Exchange. You're going to hear something different. You have to make the decisions there. We can help you deconflict. We can help you understand why some of this is there, why some of this competing guidance is out there, right? I know there's probably people in here who are not English as a first language, and begets is a word that's probably not known by a lot of people. I think of begets as one of those words from the Bible where it says that so-and-so begets so-and-so. It means it's a child, right? It means somebody had children. Complexity begets complexity. Every time you start adding in virtualization, for instance, you need to have to manage the virtualization platform. You're going to have more complex failure domains. You're probably going to have a SAN. Virtualization people are going to want you to use their HA and site resilient methods. All those things multiply that risk. When you add that SAN for the virtualization, now you've got multiple copies of the data. You've got all these things start multiplying and multiplying and multiplying. And as you start adding complexities, you now are starting to have many, many, many problems that could be happening, right? Every complexity you add adds risk. And as you go down through this list, that's risk after risk after risk that just comes together. And they're multiplicative. They don't add up. They multiply together. We draw this circle guidance here, this circle chart, and it shows in the center Exchange Online. The next line out is the preferred architecture. The closer to the center you get, the more tested and the more recommended the solution is. We believe the closer you get to the middle, the better your availability is going to be. I see someone taking a picture. You can have the slides. You can have this, right? We want you as close to the center as you can get. The further out you get, the more risk you have, the more complexity you have. One of our buddies, Neil, tells his customers, oh, you're going to put that on that SAN with those drivers and that controller card? We don't know anybody that does that. That's cool. You get to be the first. Who wants to have that risk in your environment? Nobody's ever run it on your hardware, right? We want you on the commodity servers that everybody uses. The further from the center, the less likely anyone else has ever done what you're doing. So this whole presentation has been about explaining the reasons for our guidance. We hope we kind of got that through. We don't just come up and make up, oh, you should be on physical servers. We don't make that up. We really believe that guidance through what we've learned in Office 365, what we've learned with our customers out there. Despite anything you may hear, Microsoft does see more, we deploy more, and we manage more Exchange servers than anybody in the world. So we believe we've got the right guidance. I mean, we wrote the software too, right? We like we wrote it. But if you can't follow our guidance, we think you need to go to Office 365, right? Everything we've told you comes right out of Office 365. Once again, the session takeaways, keep it as simple as you can. The more simple it is, the easier it's going to be to run it, and the more success you're going to have. All right, I think that's the end. There's probably other slides that tell you to go fill out your evals and all that kind of stuff.